we're back here with 5.6, and this is the fourth video. We're going to finish up this 5.6 section, and it's asking us to write an equation of each line in the form of x equals a, y equals b, or y equals mx plus b. So what they're meaning by that, x equals a means that it would be a vertical line, y equals b means it's a horizontal line, or y equals mx plus b would be some kind of slanted line. But we want to write it through the point 2.27, excuse me, not 2.7, 2 and 7, and parallel to this line here. So remember, to write an equation, we need to either use y equals mx plus b, where m is the slope and b is the y-intercept of 0b. Okay, well, this one here, we don't have a point that's the y-intercept, so we cannot use that one. The other way to write an equation is use the point-slope form, where it's y minus y1 equals m times x minus x1, where m is the slope and y1, x1 is our point. So we have a point here, so we just need to know a slope. But if this one right here is telling us it goes through this point, 2, 7, so we already know that we have a point, but it wants it to be parallel to this other line over here. What does it mean when two lines are parallel? It means that they have the same slope. So the slope of this line here is going to be the same as the slope we use over here when they're parallel. So that means I need to come over here and I need to find what is the slope of this line. When we find the slope of this line, we're going to have our point and we're going to have a slope. So I'm going to call this one over here, this is already in the form of y equals mx plus b. So the m for this one, I'm going to call it m1, is going to be equal to 3. Because right there, see, it's in y equals mx plus b. So if this one is 3, since they're parallel, we want them to have the same slopes. So this one, the point is going to be 2, 7, and our slope is going to be 3, since it's parallel. So we're going to use this piece of information now, and we're going to use one of these two equations to write an equation to this line. Since we said that this is not the y-intercept, we're going to have to use this point-slope form. So as I always do, I write down the formula first. I assign my x1, y1, and then I fill in the blanks. So I have y minus 7 equals 3 times x minus 2. And I simplify it. I look back to see that they want it in one of these three forms. And this is going to be y minus 7 equals 3x minus 6. I need to add 7 to both sides. So I have y equals 3x plus 1. This tells me that my slope is 3 and my y-intercept is at 0, 1. All right, so let's do another problem. Okay, here we are with number 15. We're still doing the same thing. It says to write an equation of each line in the form of x equals a, y equals b, or y equals mx plus b. So this one is going through this point. Is this the y-intercept? No, so we have to use that one. And we want it to be perpendicular to that line over there. Now, what do we know about perpendicular lines? If you need a little refresher, you might need to go back a few videos. I can't remember which section that is right off the top of my head, but to review some of that. But perpendicular lines, the slopes intersect at a right 90-degree angle, and we say that m1 is equal to the negative 1 over m2. Or we say that they are negative reciprocals of each other. So when I know this slope, I can take the negative reciprocal of it, and that would be the slope of this one over here. So here, this one's already set up into y equals mx plus b. Be cautious. They're not always going to be in the form of y equals mx plus b. You might need to solve that equation over there for y equals mx plus b. So here, it's y equals mx plus b. I already know that my m1 is going to be 1/2. So I can find my m2 over here. It's going to be the opposite sign. This is going to be a positive. So my m2 is going to be positive, and because this one is a negative, excuse me, this one's positive, so I need to make this one over here a negative. It's 1/2, so I need to do the reciprocal of it, so it would be -2. So this one, because it's perpendicular, they have the negative reciprocals of each other. So I have the point, which is -1, 5, -1, -5, and my slope is -2. So I write down y minus y1 equals m times x minus x1. I substitute in y minus -5 equals -2 times x minus -1. And I simplify, so that'd be y plus 5 equals -2x plus 1. Y plus 5 equals -2x minus 2. I need to subtract the 5 because it wants it in y equals mx plus b. Always pay attention what form they want it in. Sometimes they want it in y equals mx plus b. Sometimes they want it in that standard form, which is ax plus by equals c. So I subtract 5, and I'm running out of room there, so we'll go y equals negative 2x minus 7 would be the equation to that line that's perpendicular to the other line. Okay, here we are with number 18. It says that we want to write an equation of each line in the form of x equals a, y equals b, or y equals mx plus b. And we want it to go through this point 210 perpendicular. Perpendicular means they have the negative reciprocal slopes. And we want it to be perpendicular to the line y equals 6. Now this line up here, y equals 6, is a special one. And what type of lines are y equals 6? They are horizontal lines. So it would look like this here. This is our x and y, and this is 1, 2, 3, 4, 5, 6. Oop. That's supposed to be 6. This right here is y equals 6. It has a horizontal line. What do we know about all horizontal lines? What is the slope of all their lines? M equals 0. So we can't really write a perpendicular line. Well, I mean, we can write a perpendicular line, excuse me. The slope, I mean, we can't say what the perpendicular slope is. Because here, perpendicular lines, m1 equals the negative 1 over m2. So this one is 0. So can we take the negative reciprocal of 0? No, it's called, what does that mean when we take 1 over 0? That is undefined. So also defined in NED. Also that we know what perpendicular means, they meet at right angles. They go like this, they make like the T. So if we have y equals 6, that means that our line is going to go straight up and down, like here, somewhere. I don't know where. We look back at this point. It's at 210. So we want to go through 210. So that means it's got to go 1, 2, and all the way up here is 10. So it means that it's going to go through this line like this. Because this is what perpendicular means. It means that they meet at right angles. And this is the point right up here, 210, 2, 10. And we know that this slope is 0. So if we flip it, meaning the negative reciprocal, it's going to have an undefined slope. Undefined slope. So this one over here through 210, and it's going to be an undefined slope, means that it's going to be just simply x equals 2. That would be the line that we need. And you can see right here, all of these values for x, if we named all these points, are going to be 2, 0, 2, 1, 2, 2, 2, 3, 2, 4, 2, negative 1, 2, negative 5. Up here would be 2, 6. So when you have one that's just a y equals 6, try drawing it out, or x equals 2. If you have a vertical or horizontal line, try drawing them out first and then plotting this point and see if that can help you with there. All right, so try the ones where it's parallel on your own. And if you need some help, you know how to find me.